we have unsteady application, you will have the time as a parameter. So for each time t, you get a series of streamlines. Okay? Now, what I want you to do, find the time varying streamlines which pass through the reference point x0, y0. So if you want to find the streamlines equation that passes by x0, y0, all you have to do now is to replace in this equation x by x0 and y by y0. Okay, so you will get the streamlines equation passing by this point. So if we do this, okay, if we do this, we can get the constant c, because having a reference point will allow us to calculate the constant in the streamline. So here I want to find the series of streamlines passing by x0, y0. Okay, so the question was to find the series of streamlines passing by x0, y0. Okay, so all I have to do is to find what is the corresponding constant c. Okay, so I will replace in this equation, replacing by this boundary, I get that y0 is equal to c times x0 to the power 1 over 1 plus 2t. Okay, and now I can say that the value of c, so the constant c for streamlines passing by this point, is equal to y0 over x0 to the power 1 over 1 plus 2t. So you found the constant c for which the streamlines will pass by this point. Okay, so all you have
is t0.
نعم.
Is t0 هون إذا ما لعب x0 y0?
No, because look, at each time you have a streamline that will pass through this point. هن ما طلبوا منك at time t equals 0 to find the streamline. Okay? لو طلبوا منك انه find the streamlines at كمان at t equals 0, ساعتها you replace t by 0. هن طلبوا the time varying streamlines. يعني you will find equation of streamlines that will pass by this point at different times. Okay? يعني انت when you find this equation, you can find the streamline that will pass by this point at t equals 0. You can find the streamline that pass by this point at t equal 1. All you have to do is to replace t by the different possible values it can have. Okay?
بس المهم يمروا بالx0 والy0.
مظبوط، كلهم بيمرقوا بالx0 والy0. But the difference انه at different times. Okay?
Okay.
لانه ما عندك study application. لو عندك study application اوكي كان ساعتها فيك تجيب بكل ستريم لاين يعني كل
for any time صح.
وحده ستريم لاين بتمرق بالبوينت ساعتها. If it's study you can find one streamline passing by this point.
مش حيكون في عندنا t بالايكويشن اصلا اذا كانت study فوق.
مزبوط اذا كانت study بتكون independent of t يعني بتكون y function of x. So you replace c, you replace ساعتها x0, y0, you get c, and you find one equation, one streamline passing by the point. Okay?
Okay, thank you.
So now after you find c, all you have to do is to replace in the equation. If you replace and you rearrange your terms, you get that the series of streamlines passing by point y0, x0 are given by the following relation. Okay, so if you have they can now ask you at any time. So if as I tell you at t equal 10 seconds, what is the equation of the streamline passing by point x0, y0? All you have to do is to replace t by 10 and you directly get the streamline equation that will pass by this point at this time. Okay, so here, and if we want to sketch some of these streamlines, you can put different values for t. Okay, by putting several values for t, you can sketch several streamlines that pass through point x0, y0 at different times. Okay. Now, we'll do another problem. We will solve the same previous problem, but the only difference now, we don't want to find the streamline, we want to find the path line. Okay, the path line which passes through point x0, y0 at t equals to 0. So here they gave us the condition. We want the path line for that will pass through point x0, y0 at time t equals to 0. What is the definition of the path line? The path line tracks the particle. It will follow the particle. Okay? So what we do in this case, we should find x function of t and y function of t. To do this, we go back to the concept. What is dx by dt? The variation of x, the position of a particle in the flow with respect to time, is equal to the component of velocity along x. So dx by dt is equal to u, and dy by dt is equal to the component of velocity of the flow field along y, which is v. Okay, so now if you want to find the path line, you should integrate these two relations to find x function of time and y function of time. So if we start by, to find x, we say that v of x, it is equal to the u component of the velocity field, and in our problem the u component is given by x times 1 plus 2t. Okay, x times 1 plus 2t. So now I want to find what is x, and I know that vx corresponds to the derivative of x with respect to time. So all I have to do to find x here is to integrate my relation. Okay, to integrate, I will do separation of variables. I will take x to the side of dx and dt to the other side. So I will get that dx over x is equal to 1 plus 2t dt. Okay, and now you can integrate from each side to get x as a function of time. So you get that ln of x is equal to t plus t square, t plus t square plus a constant. Plus a certain constant. Okay, and now if you want to get rid of your ln, to have x as a function of time, you do exponential for this formula. So you get that exponential of x. But if you want, before doing exponential of this relation, how to find the constant c? Who will tell me? How to find constant c?
We plug at t equal to 0.
For
Yes,
T0,
you replace by the
X0.
boundary condition. The boundary condition is that at t equals 0, x equal to x0. So knowing that at t equals to 0, we have that x is equal to x0. Then we can get that, so ln of x0 is equal to the constant c. Okay, so now if we do exponential of this relation, okay, we can get that exponential x is equal to x0 times exponential of t plus t squared. Okay, so we got x as a function of time. Okay, now the next step, we will do the same procedure for y. Okay, we have that dy by dt is equal to the v component of the flow field, which is given by it's equal to y. Okay, it's equal to y in the given. So now we do separation of variables. So we get that dy over y is equal to dt. Okay, so simply here ln y is equal to t plus a constant 2, a second constant c2. And now to find c2, we can also do we replace by the boundary condition, knowing that at t equals to 0, we have that y is equal to y0. Okay, so we can say that ln of y0 is equal to c2. Okay, and now replacing in the equation and doing exponential. So if we do exponential, we get that exponential of ln y, which is y, is equal to exponential of t, okay, plus ln of y0, which is equal to y0 exponential t. Okay, because you know that exponential a plus b is exponential a times exponential b, and exponential ln y0 is y0. Okay, so now you got x as a function of time and y as a function of time. Okay, this is, if you want to find the path line is y function of x. In order to find the path line, you should eliminate time between the two relations. Okay, in order to eliminate time between the two, what you can do is from this relation, from this one, you can get t function of y. Okay, so let me write it here. So since y is equal to y0 times exponential t, I can go back to the previous relation. I have here that ln of y, okay, is equal to ln of y0 plus t. Okay, so you can say that t is simply equal to ln y minus ln y0, or equal to ln y over y0. Okay, and now you can replace into the equation of x the time by its function of y. In this way, you eliminate time between the two equations, and you get the equation of the path line as y function of x or x function of y. Okay, so if you do this, you will obtain the following. Okay, I don't know why I cannot erase this. Okay, anyway, by just doing the replacement now, you can get the equation of the path line and you can sketch it. Okay, so you get y as a function of x, and by doing the sketch, you will get the path line. Any question on this problem?
دكتور
Yes.
بس نتصنف كل شيء من الاول للاخر. اذا بدنا نطلع نحن ستريم لاين.
يلا, I will repeat the methodology. If I want to get a streamline, so let us do a summary. For the streamline, when they tell you find the streamline, okay, the equation to use is dy over dx is equal to v over u. Why? Because the streamline is defined as the line that is tangent to the velocity vectors. Okay?
V هي velocity in y والu velocity in x.
Yes. V هي ال component of the velocity in y, while u is the component of velocity in x. So if this is your velocity vector in your domain, okay, you have the component along x is u, this is u, and this is v, okay? And since by definition your streamline is tangent to velocity vectors, then the slope of the streamline is defined as dy by dx equals to v over u, okay? Because when you do v over u, what do you get? V over u is equal to the slope of velocity vector. And as we know, the streamline is tangent to the velocity vector, so they have the same slope, okay? So this is the slope of v is equal to the slope of streamline. This is why mathematically to find the streamline, you do dy by dx equal to v over u, okay? Once you do this, you can do separation of variables and you get y as a function of x. Okay, now in case you have an unsteady application, you treat t as a parameter. Okay, so here when you do integration, you treat t as a parameter, so you obtain a series of streamlines. Okay, now for the path line, the definition is completely different. The path line, you have a particle and you follow it through the domain. As your particle will go through the domain, you will follow it. On the other hand, for the streamline, you just look at your domain. So let's say you have, for example, a nozzle here, and you have a fluid flow over the nozzle. What you do is that at different times, you take pictures of this fluid flow inside, and you draw the lines that are tangent to the velocity vectors. If you have unsteady application, for each picture you take, you have a new streamlines. Okay? Now, for path line, it's different. You don't observe the domain, you track a particle. So let's say you have a particle here, and it will enter your nozzle, you follow it, you follow your particle. This is the path line. Now, if you have a steady application, streamline and path line are the same lines. In case you have unsteady application, they will be different, okay? And if you want to understand better the concept of path line, streamline, and streakline, I posted for you a YouTube video that is very helpful. You can see the difference between them in 3 dimensions, so you can see a practical case, okay? Now, for the path line, how to find the path line? The idea is to track the particle, okay? So to track a particle, you need to define its position and its velocity, okay? The position of the particle is given by x. So x and y will give you the position of particle, okay? And since you want to have its velocity, you have that the velocity, because it will follow the flow field, you have that dx by dt will be given by the u component of your fluid flow, which is dx, and dy by dt will be given by the y component of your velocity flow, which is dy equals to v, okay? Now, since they gave us u and v, then we know the value of u and we know the value of v. We replace in the equation. We have dx over dt is x times 1 plus 2t, and dy over dt is y. So now all you have to do is to find x as a function of time and y as a function of time. In this way, you can track your particle with time, okay? Once you have x function of time and y function of time, if you want to get your equation, your path equation, without t, you will eliminate t between the two equations. You get the equation of the path line, okay? So the first step is to find x function of t, then find y function of t, and the third step is to eliminate t between x and y. So you get a function. This function will represent the path line of your particle. Now, you have already used the boundary condition given. The boundary condition will allow you to find the constants in your integration. So you end up with the following formula. x equal x0 exponential, we said that we will replace t by its value. We got that t is ln y over y0. So by eliminating t, we replace it by ln y over y0. So t plus t square will give you this. And now you can draw your path line.
دكتور
Yes.
اذا كان عندنا ستدي فلو فينا نحن ننقي وحده منهم ونمشي عليها وبنطلع both equations للستريم ولا الباث لاين.
Can you just repeat لأنه كنت عم شوف الشات إذا حدا عم يسأل شيء. Yes, tell me.
إذا كان عندنا constant flow.
Yes. You mean constant flow with respect to time? Or what? What do you mean by constant flow?
With respect to time.
Steady.
Constant flow with respect to time.
Steady flow.
Steady flow, sorry. فينا نحن ننقي وحده من هول two equations نشتغل عليها ونطلع الفانكشن of streamline و pathline بنفس الوقت.
Yes, إذا كان عندك steady flow بتكون الإيكويشن للباث لاين والإيكويشن للستريم لاين هي ذاتها.
أزين بس أنا فيني أستعمل هالإيكويشن أو الإيكويشن اللي قبل تاعت الباث لاين.
Yes.
فيني يعني أستعمل
yes.
dy by.
If for example you want to get the streamline that pass through إذا نفس البوينت عم نحكي yes of course. يعني if you find the streamline or you find the path line passing by point x0 y0 they will be the same. Exactly. Yeah.
هيكون نفس الإيكويشن.
هيكون
يا
نفس
بستعمل dy by dx equal v over u أو بستعمل dx by dt equal u.
صح.
dy by dt equal 1.
Yes. Yes.
طيب thank you.
Welcome. Any other question?
بس مش هو تكنيكلي ان ستادي فلو ما بيكون في عندنا تيبل ايكويشن فتكنيكلي
ما بيكون عندنا تيبل ايكويشن.
دي واي اوفر دي اكس.
ما بيكون عندنا تي بس اذا عندك كونستنت فيك تعمل لها فيك تلاقي اكس. انتبه على شغله بدي اياكم تنتبهوا انه لو عندي انا يو في independent of time بس انا بس x و y will be depending on time اجباري. يعني even if u constant اذا انا بقول لك u equals to 10 اذا بدي اقول لك جيب x شو حتكون x؟ حتكون 10t plus a constant صح؟ يعني تتفهمها مزبوط اذا بتحط particle لو كان الفلو steady مش هالبارتيكل رح تمشي بقلب الدومين والفيلوسيتي تبعها والفاري لانه بالدومين you have variation of velocity with space. يعني the velocity is varying with time for the particle but not for تتوضح اكثر ليك وش حاعمل لكم سكيم صغير. Consider for example let us say I have a nozzle of increasing area يعني الاريا is increasing. اوكي انا اذا بفوت mass flow rate اذا عندي constant mass flow rate يعني عندي steady application. اوكي m dot is constant. طيب what is happening for velocity اذا باخد this location. okay let's say for example the velocity the initial velocity is 10 here and the corresponding area the area here is 5 meters square for example. okay طيب what is my volumetric flow rate? Q equals to 50 because I have incompressible flow and I have m dot constant then m dot will remain the same everywhere صح؟ but because the cross sectional area is increasing شو بيصير بالvelocity؟
decreases.
velocity decreases. يعني let's say at this section here at the final section I have an area of 10 for example. If the area is 10 then at the end at the exit what will be my velocity? So here v is 10 at the exit v inlet is 10 v exit is 20 sorry 5 we said. okay v exit is 5. طيب now for the streamlines why we say it's a steady flow لأنه أنا إذا بتطلع على location معينة if I track for this location if I observe with time I will see any variation at a certain location. يعني أنتو هيدي النقطة بحيلا instant قد إيه حتكون الvelocity فيها it will be 10 and at the exit also at any instant the velocity will be 5. But if you follow a particle if you put a particle here and you follow this particle شو عم بيصير بالvelocity تبع البارتيكل with time؟
هون it's decreasing.
عم تنقص ال velocity. This means that the velocity of particle is not steady, is function of time, okay? But the velocity of a point in the domain is constant. اوكي نحن بس نحكي بستدي ابلكيشن وقت عم نحكي بستدي ابلكيشن قصدنا انه at one point اذا بتطلع على point واحد at any time I observe the same velocity. بس here this is why for the total derivative عندي acceleration is divided into two components, acceleration with space و acceleration with time. بس يكون عندي steady flow ما بيبين عندي acceleration with time بس في يكون عندي acceleration with space due to what? Because with if I go هون البارتيكل إذا عم تمشي حتتغير الفيلوسيتي تبعها يعني I have acceleration in space in this problem. بحكي عن acceleration in space in the domain وبحكي acceleration و velocity variation in time for the particle. So to understand in a good way this concept لازم تعرفوا الفرق بين Eulerian و Lagrangian approach. In Eulerian approach I look at a fixed point with respect to space. بتطلع على point واحد وبشوف شو عم بيتغير فيه with time. إذا ما تغير بهيدا البوينت شيء with time I say I have a steady application. And to find the derivative of a certain variable I say that the derivative of this variable will be divided into derivative with respect to time and derivative with respect to space. Okay. Any other question?
دكتور مطلوب نحن عملنا نرسم الجرافس.
هلا لا مش ضروري بس مهم تعرف توصل للايكويشن. اوكي الجراف ما بده شيء it's just a function and you draw it. يعني اكيد اذا اجى شيء بيجي شيء كثير simple line او بارابولا او okay. Any other question? So please during the weekend start to look at chapter 5 لأنه chapter 5 now is just an application of the Reynolds transport theorem. يعني if you already covered chapter 4 the last section of chapter 4 introduce you to the Reynolds transport theorem and then chapter 5 will apply this theorem on different cases. Okay, so see you next time.
Thank you, doctor.
Welcome. Bye bye.
Thank you.